We have recently started working on heat waves or heat extremes. For climate action, first of all, one of the things that our group here at IIT Bombay and even several other groups are working on developing these early warning systems. So when we say early warning systems, we are trying to develop capabilities to forecast ahead of time any occurrence of extreme events such as droughts or floods or even heat waves. These early warning systems are need of the hour because they help the societies to adapt to whatever are the extremes that are going to happen. We were looking at heat waves, and the dynamics or the science behind heat waves is very well known all across the world. But in India, it's not very clearly established. So the general notion here is that heat waves occur whenever the northwest part of India or outside northwest part of India, that's Pakistan or even the Middle East, whenever the land there gets heated up, it's going to transport some of the heat into India, which results in heat waves. So that's the general notion, that there is a heat that is getting transported from the northwest or Middle Eastern region and getting into India. We were first thinking that, okay, this is the cause and we are going to use this as our basis to develop early warning systems. We typically have two types of heat waves. One is a dry heat wave and other is a moist heat wave. So when we are talking about dry heat wave, that is something that we all typically expect. That is that typically happens because of very high temperatures, and that causes the discomfort. But then we also have something called as moist heat waves, which are quite prevalent at locations where there is high humidity levels. So what happens is that in moist heat waves, there is moderately high temperature, and at the same time there are also very high humidity levels. Now, because of this combination, it causes unlivable conditions in those regions, because our body tries to maintain our ambient temperature by sweating. Okay, sweat is a way by which we cool ourselves and then survive. That's how we survive basically. But then when humidity levels are very high, our human body has to work extra hard to release that sweat. So sweating should happen no matter what. Only then our body can maintain that ambient temperature. But now when it is working extra hard, in that process we are draining out our energy, and also that's where it causes that unlivable conditions. Okay, so all of this is because of very high humidity, but at the same time we are also moderately high temperatures. So if I can make an analogy, it is almost like, let's say, if we are cooking food in a pan, we sometimes, to fasten or to accelerate the cooking, we add a bit of water and close the lid. So now what happens is, because of that, the temperature is high because the heat is on, but at the same time water that we have added turns into water vapor, and it accelerates the process of cooking actually. So that exactly what happens in a humid heat wave. So if you look at IMD systems right now, they currently monitor only temperature, purely based on the air temperature. In the context of these humid heat waves, it is not therefore possible to actually detect an onset of a humid heat wave purely by looking at only temperature. Our initial hypothesis was like, since there's an established literature about this heat getting transported, we will use that as a basis to develop early warning systems. So first we thought of looking at what is the science behind these heat waves? What are the dynamics of these heat waves? So for this purpose, what we did is we developed something called as a heat budget. Heat budget tells us, like, you can imagine like a bank where heat is getting either deposited from other sources, other regions, or heat is getting built up locally. Locally, in the sense, heat get built in two ways. One, by if a land is getting heated up, that heats the air above it. So it's again going back to the cooking example. If you heat up the pan and you put your hand above the pan, you can feel the heat. That's because the pan got heated up and that's radiating the heat up. And the other one is the air getting subsided. Okay, so when air gets subsided, then it gets warmed. So it's almost like, let's say, if you have a bicycle pump, and when you're pumping air, after some time when you hold the pump, you will feel it to be warm. That's because you're pumping compressed air into the cycle tire. So these are the three key processes that happen.